Hi guys, Mark here, Blue Glow Electronics. I got a friend who recently got a TV-7 tube tester. I helped him calibrate it, and I was looking on YouTube to see if there were any videos on how to use one of these, and there's really not much there of any good quality, I would say. So I thought I'd make one today. Let's dive in. All right, before we dive into the calibration, I thought I'd just cover a couple things about these units for you. First and foremost, these are a mutual transconductance tester. They are way better than an average emission tester. However, these are not lab-grade high-precision devices. I would say they are between 5 and 10%. So if you're trying to use it for lab purposes, probably not the right one. However, they are small, easy to use, portable, super practical. They test many types of tubes. They are good enough for almost any audiophile situation. Musicians, honestly, even for repair tech. So it is one of my favorite little tube testers, and I use mine all the time. Government specs on these things, these were not built by one company. They were outsourced to many different manufacturers. So there are variations between lots of them, even in the same model, like a TV-7/DU. I know of at least 5 or 6 different manufacturers of those. Next note, these are not really good for testing cold cathode voltage regulator tubes like OB1s, OB2s. I would recommend using a different tube tester for those. The method that they used on these, not the greatest. If you're using a step-down transformer, make sure it can carry enough current load for the TV-7 and that it can hold a constant 115 volts. Some smaller units, as you start pulling current on them, the voltage might start varying. That's a problem when you're trying to test tubes. So just get you if you're in another country other than the US, get you a nice, hefty step-down transformer. Look, don't get too wrapped up into the myth of the TV-7DU is much better than the A, B, other versions, right? It's really not. From a calibration standpoint, the DU is easier to calibrate. That's a true statement. But the others are not hard to calibrate. And the DU also has one more range setting, which almost no one ever uses. So for whatever that's worth, don't get too much wrapped around that. And last thing, these things are marked in a proprietary numbering system, 1 to 100. It is not in a scientific measurement like micromos, but that's okay. If you're just trying to match 2 tubes and you can get one of them to score a 41 and the other to score a 41, for what you're trying to do as an audiophile, a guitar person, whatnot, you're in great place. So 99% of cases, you're good to go. All right, I thought the best way to show you how to use this unit and to get acclimated to it was just to go test some tubes. So let's go. All right, first thing we need to do is acclimate ourselves with the data table. And the top lid of every TV-7 tube tester, or it should be, there's a little booklet. And that booklet contains all the tubes listed out and what settings you do on the tube tester to match up for that tube. Look, there's also, if you go on eBay, there are people that sell updated versions of the book because there's a lot of errors in the early ones. The one that's in this one right now is from the 1960s. There's some errors in them and they're missing some tubes. So you can buy a new updated book. I think they're about 20 bucks. Or you can go online and download a spreadsheet, and I'll see if I can put a link down below. And the spreadsheet has all the new modern stuff in it. But this is a typical book here, just shown on my screen. And we're going to test first a 6L6 tube. And if you'll notice right here, it has tube type listed. Then it tells you the filament voltage that you'll be setting things on. Then you get to the selectors, and we're going to talk about this more in a minute when we get to the tube tester. But really what you're doing is you are mapping out for a given tube socket, what are you connecting to each of those given pins? Which pin or filament, which ones might be your screen, which might be your plate, so on and so forth. Then you'll see over here a setting called bias. Then there's a shunt setting, and in most cases, the shunt setting, unless you're testing some type of rectifier, is just put on 0. Then you'll tell it which range, which is tied into the meter settings. This one happens to actually be range D. And then it'll tell you which button to push to read your value. And then finally over here in the minimum value column, what it tells you is a minimum value for that tube, i.e. anything below that is bad. Doesn't mean everything above that test new. And you can kind of Google, if you go online, for, hey, what might a new value be for a 6L6, and it'll tell you something around a 40 to 42. But there's no table I've found that lists that out specifically. It's just people's anecdotes they put online. And then last but not least, probably most important, is this little notation section. Now for the 6L6, there's no notation. But if you notice, if we were testing a 6K7 up here, it would tell me that I need to connect the cap to the grid. And I'll show you what that means here in a minute. And another one here, we were testing a 6J8. It would tell you, hey, what we're testing here is only the triode section. Maybe this thing also has a pentode section of the tube. And then you'll notice up here on a 6J6, there's two of them. You may say, well, why are there two 6J6s? They both are at 6.3 volts, but there's two different settings here. One's ET5 2070, one's ET6 1070. Both have the same bias, the same range, the same press, the same minimum value. But what you learn is when you have it on this first set of selectors over here, you're testing triode 1 because this is a dual triode tube. Then you have to change some things about the tube settings to be able to test the second triode inside of that tube. And if you were trying to match the triodes inside of a tube, you'd want to compare your settings on one to the other to know if they were matched or not. All right, let's go to the tube tester. All right, guys, just to orient you a little bit, typically you have your power cord wound around up here. You'll have some devices designed to be used to connect, like from the plate, maybe to the plate cap on the top of a tube here. But the most important thing up here, you've got the little booklet, but I'm not actually going to use the booklet. I'm just going to use what I'd gotten off the website there. And we're going to focus over here on the actual tube tester itself. And there's my little tag where I calibrated this unit. All right, first thing to note about a TV-7 power switch right here, you'll get a little indicator pilot light that lets you know the unit is on. Typically that is red. But inside of this, a type 83 mercury vapor rectifier tube. And so the tube filament has to warm up. It has to warm up the mercury vapor for that tube to be able to function properly. And that's typically a couple-minute exercise to get it where you want it. So I like to turn mine on, walk away, come back in maybe 5 or 10 minutes, and then start using the unit. Okay, now that the unit is nice and warmed up, we have here a brand new metal 6L6 tube, but I'm not going to insert it yet here into the octal socket. Why is that? Because I have not gone through the little booklet and laid out my settings on this unit yet. So let's take a look in the booklet here. For a 6L6, it says that the filament voltage is 6.3. And if I notice here, this is set over here on 12.6 volts. Just one little tip, 1, 2, 3 clicks takes you from 12.6 over to the 6.3. How do I know that? I'm constantly going back and forth between 12 volt tubes and 6 volt tubes. So 6.3. Up next, we've got to set these selectors. And for a 6L6, it is HS53481. So you start here with the filament first and you turn it over to H. The next one is the second filament, so HS. Then you come down here, 5 for the grid, 3 on the plate, 4, that one's already on 8, and then we turn the suppressor to 1. And what you're doing here is you're mapping out which pins on this octal socket go to the filament, which ones go to the grid, plate, screen, cathode, suppressor, and that varies between different tubes. So now we have HS53481, and I double checked that, okay. Up next, we have to look here, and the next thing it tells me is what the bias setting is on. Right now it's set on 10 over here. I'm going to turn that up, and I'm going to get my head up in here until I get that right up in there on 23. It then says that shunt has just got dashes, which means shunt is down here on 0. Only time you'll see shunt go up is typically if you're testing a rectifier tube. And then last here it says range D. And right now we're sitting on range B, so I'm going to change it down here to range C. And then it will tell me which button I will press, and it says number 3, and that is the mutual conductance button right here. And then it gives me a minimum value of 25. Okay, so we've got all the settings done. If you'll notice, what have I not done yet? I have not put the tube in. Tip number 2, always get your settings done before you insert your tube. Anyway, we've got it turned on. I'm going to pause, go away, and come back in a few minutes. I'm going to let this tube warm up for 3 or 4 minutes. All right, first thing we're going to do when we go to test a tube is we're going to come over here to this little line adjust button. We're going to hold it down, and if you'll notice, our meter deflects. The pointer goes over here, and it's not quite in the middle there. And we're going to use this little button over here called line adjust, and we're going to adjust it so you can go above it, below it, but we want to get it dead on right there in the center, and then you can let go of the line adjust button. What you're really doing is this is a potentiometer on the front end of this that basically the power cord feeds through. And you're setting this so that the tube tester is getting absolutely the right voltage coming out of your power transformer as to what this unit was when it was calibrated. Thus, when you test your tubes, you know they'll be accurate. Tip number 3, I will tell you, if you are testing multiple tubes, let's say you've got a whole box of 6L6s you want to test, and you come over here and you put the first tube in and you do your line test and it's right there. Well, you put the second tube in, you need to test the line adjust again. 2 reasons why. 1, different tubes filaments inside of them will have a different current draw, and which might pull the voltage slightly, and you need to adjust for that. Number 2, the line voltage feeding into your house can vary greatly within a few minutes. At my house, if my wife has the washer and dryer turned on, or maybe the microwave or something else, during 1 minute, then this thing might be perfectly on, and then the washing machine turns off, and I come over here and test the exact same tube, and I'm over a little bit. So every time you test a tube, reset the line adjust. All right, at this point, most people just jump into pushing the mutual conductance button and testing their tube. Keep in mind, this tube tester does not apply plate voltage to this tube until you push this mutual conductance button. At this point, all that is feeding to this tube is the 6.3 volts here from the filament. Thus, what I like to do first is I'll take the range switch and I'll turn it all the way over here to number 1 on shorts, okay? And what you do then is you tap the tube gently, okay? And you're looking for this little noise shorts bulb right here to see if you see any flashing between these 2 elements in it. When you don't, you flip it to number 2 and tap it, number 3 and tap it, 4 and tap it, 5 and tap it. Now, you'll notice here when I went from like 3 to 4 and back, the bulb glowed briefly. That does not indicate a short in the tube, that it just happens to be changing between the different short ranges here. And here's a little table that will break down for you. Let's say you had it on 3 and you tapped it and it showed a short, and you had it on 2 and when you tapped it you showed a short. You could come over here then on this little table and you could find down here where number 3 and number 2 are lit up, and what that would tell you is you have a screen to plate short based on this little table. But this one, based on the fact I tapped it all the way through these, this tube has no shorts. Very important to test before you go light this tube up with some voltages, because if this tube happens to have a short and you push mutual conductance and it does have a problem, you can blow out one of the 47 ohm resistors on the gang stacks on these and then have to get your tube tester repaired. All right, at this point, all the hard work is done. We just need to get this back over here on the proper range D. And then what we do is, let's check the line. Check again, we're close on right there. We then will hold down the mutual conductance test. And what does that come up as? And you have to realize that these numbers here, each one of these little lines, so there's 40, right? Between that and 60, there's 10 lines. So there's two units per line. So if you're halfway between 40 and the next line, then that would be 41. But if you're all the way on the next line, that would be 42. And as I test this right there, it looks like we're sitting at 41 for this test. So at that point, it's as simple as, ooh, and that tube is kind of warm. It's been on for a little bit. We can pull that tube out, we can put the next one in and test it. And we don't have to really do anything other than I would recommend doing the line adjust. Okay, and the final test we're going to do before we move on to testing another tube is a gas test. And I'm just going to perform this test on this tube. The remainder of the tubes I test today. I won't go through those same steps just to save time. But you would do this with each and every tube that you test along the way. So what you do here, so we got the line test, everything, this thing, we showed it tested around the 41. You're going to want to hold down this gas button, and quickly you're going to want to turn your bias meter, and you want to adjust your bias meter all the way down till you're on 10. It's a little touchy right there. And honestly, it doesn't really matter if it's on 10 or if it's on 20 or wherever. Look, if you can't get it to go down to 10, what the manual says to do is get it aligned over here on 100. So either one of those can be fine. But once we get this aligned on a 10, then you hold down gas 2. And if there is more than one little meter movement away in deflection when you push down that second one, then you have a gassy tube. In this case, we are moving less than 1, so we are good to go on this tube. And that's how you test shorts, mutual conductance, and gas on a tube. One little note on testing gas. For really high transconductance tubes, and one of them I know of is an EL84, sometimes it'll throw off this gas test. So if you run into like an EL84 or other super high transconductance tubes, you might want to do some Googling on that, because just because they show gas doesn't always mean, in other words, you can get a false positive on some of these. Okay, up next I've got a little Hewlett-Packard made in Holland, otherwise Amprex 6DJ8, otherwise known as an ECC83, that I thought I would test. By the way, this is a dual triode tube, so there's actually 2 tubes inside of one glass. So let's take a look at the settings here. First off, it's still a 6.3 volt tube, so I don't have to change anything related to that. But the setting here, the first one says EV7, so let's change this over. EV7 6080. Okay, and then what does it say next? The bias over here. It's got to be spot on 20. And the shunt is 0. We're still going to test on range D. Tells us to push mutual conductance. But first and foremost, I am going to put this tube in here and let it warm up for a few minutes. Look, the amount of time between testing tubes varies, okay? I like to let each one warm up for at least about a minute. More than that is good if you can, but if you're testing a whole bunch of tubes, that becomes very time consuming. But I think 60 seconds is a good number here. While this tube is warming up, by the way, you can go ahead and get your line adjust in line. I would set it again when you go to test the tube, but at least then, because this line set also affects how much filament voltage is getting here, so at least you know your tube's getting the right amount of filament voltage while it is warming up. Okay, we've got the tube completely warmed up. Real quick, always just do the quick line check. Then over here, it looks like this tube tests out right at 83, right there. So not bad at all. Okay, now we want to switch over to the secondary part of the tube, i.e. the second triode inside of this. And if we go look at the manual here, what we see is it is EV21030. And if you'll notice, E and V, the filaments haven't changed, so we don't have to touch those. And because of that, we don't have to pull the tube out, okay? So we can just come over here and say EV2, and then it is 10, 1030, still range D, okay? Let's do our quick little line adjust test, and then we can test this, and it looks like that is dead on 80. So we've got a fairly close tube, 80 and 83. You know, that's within 5% tolerance of being, it's good tube. Not perfectly matched, but pretty close, within 5%. And that's how we would test that. Let's test one more tube just to make sure we get all this right. Okay, what I've got here is an 807 tube, brand new RCA. We're going to test it, and if I look at the settings on it, is FR30240. It is a range C. The bias needs to be set on 33, so about right there. And then this is a 5-pin tube. So I'm going to put it into the 5-pin tube socket right here. But if you'll notice, the plate cap for this tube is sitting on top of the tube. So I need to plug this in, plug this on top, and at this point I can come over here and do my line adjust voltage. We're going to let this warm up for 1 minute. I'll be right back and we'll test it. And when we hit the mutual conductance, just do the line check one more time, mutual conductance, we're sitting just a hair over 90, not quite 91, maybe 90 and a half, and 48 was a minimum setting. I told you this was a brand new tube, really nice testing tube, but that's how you would use the external connection on this. All right, just to close this video out, just a few other tips here on the TV-7. In the top, typically you will have a couple socket adapters here, and it'll tell you in the book if you need to use one of these socket adapters, much like we use this little adapter here for the plate cap. Some tubes will have an external grid. This one, the 807, happened to have an external plate on it. And by the way, these two little units right here are invaluable. So you got a little tube like this, 9-pin, maybe the pins are not completely straight on it. You just put it in here and you just kind of start working it around slowly until you can push it down, and then you pull it out and it'll have your pins straightened right out. If your pins are a little too far bent for that, you can always use a pair of needle nose pliers and grab them at the base and pull them over slightly till they're close enough in line, and then this will help you straighten them right out. And my last tip for you would be to always keep socket saver units on top of these. And you can buy these online. I've seen them on eBay or whatnot. They have a little bolt that goes down through and tightens them up. These, the 7-pin, the 9-pin, and the octal here get a lot of use, very commonly used tubes. And you want these socket savers to wear out and not actually the sockets in your unit. And I end up replacing these every 10, 15 years because I do a lot of testing on my unit. One final closing thought for you guys. I have a couple other TV-7 videos out there. One is on how to repair and fix a rectifier diode in this that is a common failure problem. 2, I have a full video on how to calibrate the TV-7 tube testers. And 3, on my eBay store under Blue Glow Electronics, I sell calibration tubes for the TV-7. If you decide to go down a path of calibrating your own, you're going to need a set of reference tubes to calibrate that against. With that, thanks everybody for watching, and we'll see you guys again soon.